Please welcome President and CEO of the Doris Duke Foundation, Sam Gill.
Hi, good morning. Good morning and welcome. Whoa, how about that? It's a nice sting. That at every meeting I walk into, that happens at the beginning. I should be used to it by now. No, thank you all for being here and for joining this really important conversation. Today we come together to celebrate 25 years of Doris Duke Foundation support for promising physician scientists. We also come together, we hope to ask questions that we feel will be provocative about what the future of biomedical innovation can be. And so to help set the stage for the discussion today, I'd like to make a few remarks about that future, but first I want to thank a few people in particular. The role of this event as both celebration and exploration is really the vision of our extraordinary medical research team, Cindy Escobar-Alvarez, Kevin Sia, and Karen Hahn, aided by Chief Program Officer Maureen Knighton. So please thank them for the work they're doing. Nor would today really have been possible without some former colleagues who were instrumental in conceiving and building Doris Duke's medical research program, who are also here, Elaine Gallen and Betsy Myers. And if you could just raise your hands so we could acknowledge you. Thank you. I'm also delighted that some of our trustees will be joining us for part of today's program and for the program this evening. And really none of this would be possible without their support and their endorsement. And while he's not here right now, but will join by video later, a really especially important part of our board in this work has been Dr. Anthony Fauci, who's been a trustee of Doris Duke Foundation since our inception. And finally, I'd like to thank all of you, 25 years of the Clinical Scientist Development Award represented here today. We very proudly made a bet on each and every one of you, and each and every one of you has made us look really good, which we appreciate. But your tireless work and contributions have literally changed the world. And so we sincerely thank you for what you do and what you represent. So Doris Duke Foundation works to build a more creative, equitable, and sustainable future. And I want to begin my remarks really talking about our founder, Doris Duke. I think two words really describe her. First, she was modern. She evolved with the times in her tastes, in her passion, in her philanthropy. She was always of the moment that she was in. And she was transgressive. And by that, I don't mean breaking the rules so much as recognizing that when old ways of thinking have become obsolete, that we need to see things in a different way. And in this spirit, we really see ourselves at Doris Duke Foundation as practicing kind of what we think of as a philanthropy of now. A philanthropy of now is realistic and alive to how the world is fundamentally changing. It's creative in its imagining of different possible futures. It's optimistic in its confidence that these futures can be rigorously obtained, delivering on their possibility and their promise. And it seeks to use tools well beyond grants to advance social progress. A philanthropy of now is also willing to respond with impatience and with novelty, in large part because so many social, economic, and political paradigms that had been stable for over half a century are beginning to fracture and wilt and obsolesce around us. And so I'll come back to how we intend to apply this outlook to our work in support of physician scientists. But first, I want to begin by recognizing that the assembled physician scientists in this room are really the apotheosis of two very powerful ideas that have impelled the intellectual history of the human species. The first idea is that the universe and every physical object within it can be described objectively in some way, which is to say that the physical universe is knowable independent of our subjective experiences. And the second idea is that the greater our objective knowledge of the universe, the more effectively we can exert control over it. And these two threads connect ancient natural philosophy to modern science. They link our species across the ravages and vagaries of time. They represent a common yearning, a shared dream to know more and to do more. And they also describe the essential mechanics of basic biomedical research. First, we articulate a fundamental natural mechanism, today likely a phenomenon at the molecular level, and then we translate that mechanism into a therapy, first understanding, then control. And the core article of faith among scientists is that advances in science reflect improved accuracy in detection, better tools to perceive this universe, and improved method, better tools to interpret the universe. So the microscope is a better tool for perception and detection, and calculus is an improved method. And the rub is that we also know from history that our subjective beliefs, biases, preferences, and desires can subtly and subconsciously shape the process of objective inquiry. So a core issue for science then is not to pretend that science can be some perfectly hermetically sealed objective domain. It's instead to discern when our subjective beliefs and biases are influencing science, and most especially how they're influencing science. And to make this a little more plain, I'd like to tell a story. It's one that some of you may have heard before. When I was a young teenager 1,000 years ago, the science historian Doris Sobel wrote a best-selling book on the problem of determining longitude. And so why was this such an important problem? Well, because the Earth doesn't spin on its horizontal axis. Latitude, which is position relative to the North and South poles, is relatively easy to calculate. Zero latitude is the unchanging midpoint between these two poles. And so even ancient mariners could calculate their actual latitude using fairly rudimentary instruments and techniques. But longitude is much more difficult to determine because it's a function of time. The core unit we use to measure time is a single revolution of the Earth around its axis. So longitude is therefore a physical location that corresponds to a time in the day. And a given longitude will have a different position at a different time of the day to the extent that these two different times are, by definition, these two moments in the Earth's spherical rotation. So the key to longitude then is this. First, to know the time at a set reference point. Second, to know the local time. And then you can calculate the distance. And for centuries, the inability to easily and accurately pinpoint one's location cost countless money and thousands of lives in preventable shipwrecks. And the problem was so pronounced that several nations offered prizes to anyone who could devise a solution. And the most famous of these was the British Parliament's Longitude Act of 1714, which established a prize of £20,000 for a solution to longitude that was accurate within half a degree of longitude. So in today's money, that prize would be worth about $4 million. In the end, the winning solution came from the clockmaker John Harrison. Harrison developed a portable timepiece that would keep time true amidst the rolling waves and inclement ocean conditions. So by comparing a local time reading to the watch, which was set to the point of origination, sailors could ascertain an accurate longitudinal reading. Now, Harrison never received the official recognition of having solved the longitude problem, and he didn't receive most of the prize money until the final years of his life, despite having cracked the problem nearly 20 years earlier. So why not? In the dramatic retelling that animates Sobel's book, Harrison is foiled by his arch-nemesis, the Reverend Neville Maskelyne, who is also the royal astronomer. And Maskelyne and Harrison are not only in competition to be first to the solution, but they also pursue entirely different approaches. Harrison, as we've seen, believes the answer is a clock or it's a watch. And Maskelyne was an ardent advocate of what's known as the lunar distance method, which takes the distance between the moon and some other celestial object, which is then compared to a seasonal almanac to determine the time at whatever line serves as zero longitude. And the climactic coup de grace comes when Maskelyne, despite his vested interest in the lunar method and avowed distaste of the clock method, is actually placed in charge of evaluating, independently, the track record of Harrison's longitude clocks, which of course he criticized and panned. And the reason Harrison and his clocks elicited such a strong negative reaction from contemporaries like Maskelyne had to do with the scientific culture that privileged mathematical astronomical science. As Sobel writes in the book, the Board of Longitude would not welcome a mechanical answer to what it saw as an astronomical question. The board was top-heavy with astronomers, mathematicians, and navigators. Indeed, generations of natural philosophers and scientists, from Galileo to Newton, assumed that the answer to longitude was to be found up in the heavens, not down in the gears of a watch. And Harrison's only flaw was that watchmaking was considered a craft rather than a science. Harrison, a craftsman, not a real scientist. And so I think this story powerfully demonstrates that the scope of scientific objectivity in a given moment, in a given epoch, is always subject to cultural forces that are anything but objective. These forces may even emanate from within the scientific establishment, as they did around the problem of longitude. But the point is that an idea's currency with a society is not solely the product of its objective veracity. It's at least in part a function of who has the power to set the agenda. Or as Darren S. Moglu and Simon Johnson of MIT write in their sensational new history of the relationship between technology and prosperity, quote, "Whoever asks the questions, sets the priorities, and rules options in or out, has formidable powers to frame public discussion and convince others," end quote. And so this is a sobering challenge to even the most basic conception of scientific merit. All of you would seem to be the best evidence we have that hard work, technical competence, and ingenuity will ensure that the right ideas rise to the top. Yet what John Harrison's experience so vividly demonstrates is that that's just not enough. What that may also mean is that you all are not only at the zenith of scientific thought as we know it, but you may also unintentionally be the guardians of a very particular scientific outlook. In other words, the scientific questions you ask and the ways that you go about answering them could be taken as standing in for what the rest of us, kind of mere mortals, think that science is. And so let me say a little more about what I mean here. Fairly early in your careers, it was probably clear to you what the conventional path to success would look like: a medical degree and possibly a PhD, a subspecialty fellowship that often extends for 1 to 2 years beyond the minimum requirement, postdoctoral research training, and then advancement through faculty ranks from assistant to associate to full professor. And as we know, financing this career progression are a series of awards from the National Institutes of Health, the largest public funder of biomedical research in this country. So this is principally the K, R, and P awards that you all know well. But this pathway obviously didn't come down the mountain with Moses. We created it. We created this esoteric system because we believed, likely correctly, that each of these stages corresponds to the refinement of an individual's ability to deliver on the key ingredients of biomedical innovation. And what is important to remember is that this system was designed to serve a particular outlook on what science was for. Now, I think that outlook was perhaps best articulated by Vannevar Bush in his landmark report, The Endless Frontier, which is probably like the single most famous piece of science policy writing, certainly in modern history. And the report, released in 1945, was intended initially to provide a roadmap for how the US could extend into peacetime the fecund scientific firmament that had impelled so much innovation during the Second World War. And Bush famously made the case for a national science policy that was committed to basic research. So the famous quote is, "Basic research leads to new knowledge. New products and new processes do not appear full-grown. They are founded on new principles and new conceptions, which in turn are painstakingly developed by research in the purest realms of science." And so Bush recognized that the priority of basic research, though, is not an immutable principle. Indeed, in a less quoted section of the report, he reflects that, quote, "In the 19th century, Yankee mechanical ingenuity, building largely upon the basic discoveries of European scientists, could greatly advance the technical arts. Now," he says, "the situation is different." The direct result of the report was the creation of the National Science Foundation, but the effects were far more far-reaching. Likely no single document is more responsible for the modern American research enterprise, including the tens of billions invested annually by NIH and American universities in biomedical research. And so the point that I'm trying to make is that how science is organized does not merely reflect objective facts about the nature of discovery. It also reflects an outlook or an opinion about what kind of science, what kind of knowledge really matters in a given moment. And we're the inheritors of a system of science designed to emphasize basic discovery as the critical imperative for the practical application of knowledge. And that outlook shapes what research questions are seen as important, and by implication, which ones are not. It shapes what methods and approaches are seen as valuable and feasible, and which are not. And due to the scale of funding, this opinion also shapes the institutions that undertake research, including our great research universities and centers of academic medicine. And a central part of the economic model of these institutions is based on how federal funding is structured. So that, in turn, means that the formal and informal systems of incentive, recognition, and advancement for individual careers in some way reflect this larger scientific outlook. So what we have is this whole logic about the importance of basic research that has suffused and penetrated every aspect of our research enterprise, including among research funders like Doris Duke Foundation. And the point, if there is one, to this long disquisition is really to provide the context for our changing view at Doris Duke Foundation about our role in impelling the future of biomedicine. And our charge, is laid out in Doris Duke's will, is to focus on, quote, "actively and efficiently promoting medical research designed to effectuate cures of major diseases," unquote. And 25 years ago, this led us to focus on the role of physician scientists for at least 3 reasons. First, as I just detailed at great length, you are the apex predators of Vannevar Bush's endless frontier of basic research. Today, medical doctors remain in the top 1% of NIH-funded researchers. Second, our resources, especially by comparison with a biomedical research enterprise that expends more than $40 billion annually, are modest, to say the least. So we need to find partners whose research significance to science was sort of in inverse proportion to its size. And third, we recognize that if our investment could help get a career off the ground, we might be able to help society reap the long-term benefits of that career. 25 years later, we have invested $318 million in over 2,400 research careers. In the clinical scientist development program alone, we have invested $175 million in 383 researchers from 150 institutions. And as impressive as these numbers are, they're not what matter, right? What we are most proud of is having taken a chance on people who identified how cancer immunotherapy works, paving the way for precision medicine. People who helped to lead the first FDA approval for a virus that can kill cancer. People who identified how gene therapy can treat heart attacks. and people who developed in a matter of months a vaccine to address a pandemic. And these are just a few of the ways, and I know just a very small few of the ways, that your mastery of the contemporary scientific research paradigm is literally changing the world we live in. Your combined work has likely saved millions of lives, undoubtedly improved millions more, and will form the basis of future treatments and therapies that we have not yet even imagined, but that through your ingenuity have essentially become inevitable. So despite, or perhaps because of this incredible success, we at Doris Duke Foundation have begun to reflect on our role. How is biomedical science changing in ways that influence our thinking? Well, first, we think non-basic areas of research, like health services, are beginning to really assert their rightful place as a core priority, one worthy of greater funding and attention. There were many lessons from COVID, scientific, administrative, cultural. We'll hear about them. We have experts in those lessons here today. At least one of them, for me, was that the society part of science and society is really life and death. And the medical miracle that was a commercially ready and historically effective COVID vaccine within 1 year of the onset of the pandemic is a triumph of science. And yet we stand here today having vaccinated less of the population than we'd like to and that we could, despite incredible efforts by public health administrators and officials and so many people on the ground. And that has to do with factors that have almost nothing in a way to do with science. They have to do with things like ideology. But while COVID paints an especially vivid picture of the relationship between the role health services play and our commensurate investment in related research, the problem is much deeper and is a structural feature of our research enterprise. For example, our society, as you probably know, spends much more, substantially more, on hospital services than on drugs every year. Yet research expenditures on therapeutic development far exceed investment in new knowledge regarding potential health services improvements. And this gap doesn't result from a shortage of talented researchers or a dearth of opportunities. Instead, we think it may be our overemphasis on one pathway to innovation, namely basic research on disease mechanisms, and the relative derogation of other equally valuable or also valuable kinds of innovation. And at Doris Duke, we think there is a clear need to be in identifying and supporting more research that's focused on preventing disease, on improving care delivery, on translating promising interventions into practice, and strengthening health systems. So that's one change. Second, it seems clear that computational power may fundamentally change the physical requirements of research. An important role of research universities in the endless frontier model has been to provide the physical plant for lab-based research. So as of 2021, there's 236 million square feet of research space across institutions that are spending at least $1 million a year on research. And biological and biomedical sciences are 25% of this total. Yet computationally driven research, such as machine learning and AI, may change the capital requirements of the next generation of research. The amount of compute power used by contemporary AI is staggering. For example, I asked ChatGPT about the difference in parameters between its models. And ChatGPT version 2 had 1.5 billion parameters, and version 3, which is the freemium version that I used, has 175 billion parameters. This reality shapes entire value chains. AI startups spend 80% of all capital on compute power. I just saw a statistic this morning as earnings come out for the technology companies that artificial intelligence computing is driving all capital expenditure increases, which are in double digits now. Google estimates that 15% of the company's energy use powers AI development, and that's an annual watt hours equivalent to all the homes in Atlanta. And that's the capital side, but computational talent is also an issue that will challenge the university and academic research enterprise. Among major sciences, biomedicine and related fields have the highest share of university employment at 39.5%. It's actually almost higher than the social sciences, which blew my mind. In computational sciences, that falls to less than 10%. 3 in 4 computer and mathematical sciences degree holders go to for-profit companies. So universities will not be able to compete or even catch up if they transpose the conventional lab model onto a field increasingly driven by computational methods. The cost of capital is simply too high, and much of the talent has already fled, and those are powerful path dependencies. But universities and academic research obviously have a vital interest in harnessing these tools and shaping the questions that we ask of them. Much of today's cutting-edge research in biomedicine connects the bedside to big data. That's what so many of you do so effectively. So this requires doctors and other professionals to work side by side in new ways. And we think this suggests academic medicine in particular must continue to rethink an entire research model, from the organization of labs and teams to the financing tools that shape how researchers work together or how they don't work together. It may mean adjusting research support that is traditionally based on the track record of individual scientists who lead discrete, disconnected projects, or rethinking career incentives that often reward individual contributions. They may also mean that university-industry partnerships will have to look different in a world in which the computing power and talent may be almost exclusively furnished by private sector players. So that's the second. Third and finally, we believe there's an important and overdue shift in our thinking about who a qualified researcher is. There's no question that the arduous training required to get an MD, a PhD, and then the postdoctoral training required to be a physician scientist is essential to so many breakthroughs. And we thank you for the time and effort that you've put into your training and to the training of others who work with you. We also believe, however, that there are important contributions, what we could call expert contributions, to be made by people with different credentials. We already mentioned computational science, including individuals outside of biomedicine who might know how to apply computational tools to biomedical problems in novel ways. But there's other experts as well. One example that many of us are familiar with, some of us may lead, are research nurses who are leading studies to improve practice in care settings. There are examples of community-engaged research through tools like research practice partnerships that partner with community-based organizations. This work valorizes the importance of practical research that focuses on the delivery of therapies and treatments, including non-technological treatments. It also validates knowledge that is well outside the ambit of the technical information taught in medical schools, but knowledge that is nonetheless extremely relevant to the provision of care. Indeed, we should see the challenge posed to medicine by such issues as community relevance and lived experience, not as a challenge to scientific rationalism as such, seeking to displace it, but rather a challenge to the exclusionary way that science can be practiced. In other words, social knowledge should never be seen as inimical to scientific knowledge, but rather as something that can extend and deepen the power of scientific knowledge to improve our lives. I want to be clear in offering these reflections that our view is manifestly not that the dominance of basic research is somehow obsolete. Far from it. The historic and continuing advances of the endless frontier era of science suggest there's a heck of a lot more frontier left to explore. And maybe that's even where the bulk of our investment as a society should continue to go. Our question is whether we at Doris Duke Foundation should be contributing further to the current paradigm of biomedical innovation, or whether we should be supporting those individuals and institutions that are seeking to blaze new and different trails. This inquiry is in part motivated by our view about what the role of philanthropy should be. We don't believe we're here to do what government does. And this is not just a mathematical inevitability in light of our mere millions against a $40 billion pie annually. It's really a philosophical question. And this sort of brings me back to this idea of a philanthropy of now. A philanthropy of now reflects the modern and transgressive ethos of Doris Duke. It recognizes that at a time when new paradigms of thought and action are desperately needed in all fields, including medicine, and at a time when the pathways to social progress are changing quite rapidly, then the appropriate response for independent philanthropic capital is to take risks that others cannot in order to inspire, inform, and shape new approaches to complex problems. As previously announced, this does mean that we are putting on hold our major career support awards for physician scientists, like the Clinical Scientist Development Award and the Physician Scientist Fellowship. We are not, however, I want to be clear about this, divesting from physician scientists. We are recommitting to the core virtue of physician science, the connection between the patient and discovery and knowledge, by investing in pathways to innovation and advancement that are not well supported in the existing biomedical enterprise. We want to find and help the researchers who are taking creative risks that could change medicine, even if they don't provide a clear path to an R1 today. We want to enable and uplift the researchers who are tackling non-etiological problems that nonetheless have the potential to revolutionize how we apply modern medical science to the realities of a complex society. We don't know exactly what shape our support will take. We don't at this stage, really. And we're not going to rush to an answer. Instead, we hope that today is an opportunity to convene a new conversation, a different conversation. Over the next year, we want to talk to you and your colleagues, as well as individuals from across fields, disciplines, roles, within and without academic medicine, about the promising pathways to innovation that have yet to be championed, but that might benefit from our modest but meaningful capital. We're looking for the ideas and approaches that are not ready for the mainstream funding vehicles of the biomedical enterprise of today, but may well determine the shape of that enterprise tomorrow. We're looking for the John Harrisons alongside the Reverend Maskelyns and the Isaac Newtons. Through these discussions, we hope to alight on a new approach to Doris Duke Foundation funding in which we can play a different but still essential role in supporting the work of promising physician scientists. So we're inviting you, we're exhorting you to be the Vannevar Bushes of today, to look up and out over the long arc of time, and to ask what kind of science we need, and not just for today, but for tomorrow. To recognize, as Bush did, that shifting epochal priorities are not a symptom of human fallibility and fickleness, but a symbol of science's capacity intrinsically for progress and for improvement. And indeed, I think you'll see further, frankly, than Bush and his contemporaries ever could, for you are fortified with what I suspect is a much more inclusive and morally ambitious vision for who can do science and for who science is for. So please allow me to congratulate you sincerely and earnestly on all that you have accomplished, to thank you for joining us today in charting a new vision and ambition for medicine. I really hope you have a great day. We couldn't be more delighted that you're here with us. Thank you very much.